All right, guys. Before we get started, questions over the homework. Questions over the homework assignments.
I'm gonna do it tonight.
I'll do it
tonight. I'll do it next week. It's due tomorrow, right?
End of the chapter. We still got 2 more sections.
I don't cheat. I'll turn it in tomorrow. I'll do that tonight.
Yep.
That'll be done.
Yeah, it would be.
I got you next year. Wait, is this 1.4?
This is 1.5.
Dang it! Where is that?
So, when we look at this here, again, 3 variables, 3 equations. 3 equations with 3 variables. We need to pick one of the variables to eliminate out of the other 2. Because we finished with this one yesterday, didn't we? That's right. I was mixing the 2 of y'all up because 2 of the hours finished this one and the other 2 didn't. So here, we're starting here. X, Y, and Z. All right, guys, focus in. We need to figure out which equation or which variable we want to eliminate first. Now this one, unlike the first one, all 3 we can actually pick, either one, any of them. Because in the first one, we have 1x, 1y, 1z. So with that, I can easily turn that first x into 5x or 4x. With y, we can easily turn that y into 5y or just y. And with z, we can easily turn that 1z into 5z or 3z. Which one do we want to eliminate out of all 3 first? X, y, or z? Y, because 2 of the equations already are the same, yes? So, that makes it a little bit easier to work with. Do we want to use the top or bottom equation as our eliminator equation? The bottom one. Yeah. Now we'll write the other 2 equations out. Now, since the equation on the left, the y values already match up, they are already the same, we can just put it in there. We can fill it in because the y values already match up. Now, looking at this here, would we add or subtract? Y plus y is 2y. So we would need to subtract because we want y to become 0. So y minus y is indeed 0, so we're going to be subtracting all the way through. Now, x minus 4x is going to be negative 3x. Y minus y is still 0. Z minus negative 3z. Well, the negative and negative will make a plus. Plus 4z. 2 minus 6 is negative 4. So we have negative 3x plus 4z equals negative 4. Now for the other equation, we need y to match up with 5y, yes? So for those to match up, we need to get those y values to be the same. So for the bottom equation, our 4x plus y minus 3z, we need to multiply this entire equation by 5. Now 5 times 4x is 20x. 5 times y is plus 5y, and 5 times negative 3z is negative 15z. And negative 6 times 5 is negative 30. Question? Yes. Okay. Yeah, I scrunched it in a little bit on that side. Now, our 5y and 5y, would we add these or subtract these to get these to be 0? Subtract, because 5 minus 5 would indeed be 0. So we're going to subtract all the way across. 5x minus 20x would be negative 15x. 5y minus 5y is still 0. 5z minus negative 15z. Negative and negative would make a positive. So 5z plus 15z is 20z. 3 minus negative 30. Well, the negative and negative would make a plus. 3 plus 30 is 33. So we've gone from 3 equations with 3 variables to 2 equations with 2 variables. Which variable do we want to eliminate next? So x or y? X? Yeah. So, and we would indeed use the equation on the right. We're going to have to scale it up. So to get 3x to be the same as 15x, we need to multiply our 3x plus 4z by 5. We'll also have to multiply the negative 4 by 5. 5 times negative 3 is negative 15x. 5 times 4z is plus 20z. Negative 4 times 5 is negative 20. Questions on how we got to this point here? Now it is interesting, the left side, our x and z are the same, yes? So let's see what happens, because here we're going to need to subtract, because negative 15 minus negative 15 is 20 minus 20. So everything on the left side became 0. Negative 33 minus 20. Well, the negative make a, which would be 53, yes? Is 0 equal to 53?
No.
So this is not a true statement, is it? So there is no solution. Now, if we get this at any point where we get 0 equals a number, we get this false statement, we are done. Here, it worked out that it came all the way at the very end that we got the false statement. Does that make sense? Because at this point, we're done. We can't go any further. This is it. Now, if we got it earlier, instead of getting one of these two equations, we got 0 equal, say, negative 7, we'd be done. We don't have to find the rest. We have a false statement. Those two lines, or those two planes do not intersect. They do not cross. So we're done. Because, again, for us to have a solution, we have to have all 3 intersect. As soon as we get a false statement, it means those 2 planes don't intersect. There is no solution. There is no place where all 3 cross. Does that make sense? Okay. Let's look at the next one. X minus y plus z equals negative 3. X minus y minus z equals negative 3. 5x minus 5y plus z equals negative 15. We have these equations here. Now, just like the previous one, x, y, and z, all 3 are kind of nice. We can easily get the others to eliminate. So which variable do we want to eliminate first, x, y, or z? We can do z. Z is nice because all 3, we have one z, yes? Top, middle, bottom. Which one do we want to use as the eliminator equation? Middle? All right. X minus y plus z equals negative 3. 5x minus 5y plus z equals negative 15. Now, luckily, z is already the same. We don't have to do anything to it to get it to be the same as the other two. Now, the one on the left, would we add or subtract? Because z minus negative z, well, the negative and negative would make a positive. So z minus negative z is the same as z plus z, which gives us 2z, yes? So we can't subtract, we would, because z plus negative z is the same as z minus z, which is 0, just what we wanted, yes? So we're going to add x plus x, 2x, yes? Negative y plus negative y, negative 2y. Is negative 1 plus negative 1? Now you're good. Now z plus negative z would be 0. Negative 3 plus negative 3 is negative 6. So we have 2x minus 2y equals negative 6. Let's look at the other equation. Z and negative z, would we add or subtract? We would. Because z plus negative z, z minus z would indeed be 0. So here we're going to have to add. 5x plus x is 6x. Negative 5y minus y, or 5y, negative 5y plus negative y is negative. Negative 15 plus negative 3 is negative 18. Which variable do we want to eliminate next? X or y? Y. Now, we can keep one of these the same, because can we multiply this 2y by a number to get 6y? Yeah. We can multiply it by 3. So we picked the left equation to multiply it by 3 because it's easy to get it to be the same as the other y. Now, if there's not one, we have to multiply both equations by a number to get them to be the same. Now, 3 times 2x is 6x. 3 times negative 2y is negative 6y. Negative 6 times 3 is negative 18. Add or subtract? So negative, because we said y, yes? Negative 6 plus negative 6, is that 0? No. So we would subtract. Negative 6 minus negative 6. Negative 6 minus negative 6 is 0. So these would, so we've got to subtract all the way across, yes? What's 6x minus 6x? Well, that's not looking good because the whole left side became 0, yes? Let's check the right side before we call it no solution. Negative 18 minus negative 18. Is this a true statement? So it tells us that there are infinitely many solutions. There's infinitely many solutions. Now, there is a set equation for it. I'm not going to ask y'all to go about finding it. If we get this identity, we are going to have infinitely many solutions. Now, I will preface this. If you got 0 equals 0 in this spot here, do check the other side. Especially you eliminate the first one out, you get 0 equals 0 for 1. Check the other equation, eliminate that same variable out on the other side. And the reason I say that is it could be that we do get 0 equals 0 on one of them. But if on the other side we get 0 equals 1, that's no solution. Because if we get a false statement at any point, okay, it's no solution. Because it could be that those two planes were parallel or the same plane, the other was parallel to it. So we got to make sure. And x plus 3 and 0 is actually the equation for the infinitely many solution. So for any value of x, we could plug it in as x plus 3, and it would actually give us a point that is a solution for this here. As the new safety officer was in here earlier, I don't know if you heard me make the comment, he was talking about the solutions for this one. I did say that there were a lot of solutions for this. There's infinitely many. So there's a good chance he could have actually picked one that was a solution. But questions on this here? Be ready for the next one. Which variable do we want to eliminate first? Because x, 3x, and x, we can make one of those two 1x's become 3x, yes? Z, we have z, z, and 4z. We can make one of the 1z's 4z. We can eliminate them out, yes? What do we have for y? All of them are 2y. Do I need to change anything to make it be the same as the other? Might as well just pick, nope. Because here, it doesn't matter which one we do. If we pick x, so I say we'll still say with the top one, to eliminate x out of the bottom equation, we don't have to do anything. They're both 1x because they already match up. But if I want to eliminate x out of the middle equation, I'm going to have to multiply that middle equation by 3 to get the x and 3x to be the same. Yes? Because the only way we could eliminate y here is if this y and this y had the same value. So we had to multiply this equation by 5 to get the y values to be the same. Here, if I want to do x, these are already the same. These are not. So I'm going to have to scale this up so that the x values are the same, and they will eliminate out. Does that make sense? No? Okay. Here, what's the values for y? What's the value for the y? 2. All of them are 2. Are the numbers here the same? So do I need to do anything to the eliminator equation? So we'll say this one to make them be the same as these. No. So it makes it easier to work for this one here if we eliminate y first. Because if we do x or z, we will have to change the eliminator equation for one of them to get that value to be the same so that we can cancel out the variable we've chosen to eliminate first. Now, because we chose y to eliminate first, and our y values are all the same, we don't have to do anything to y, our eliminator equation, to get them to match up, because they already do match up. So if we look at the left, 2y and negative 2y, would we add or subtract? Add 2y plus negative 2y. 2 minus 2 is 0. So that does cancel those out. So we're going to add the two equations together. Now 3x plus x is 4x. 2y plus negative 2y, we already did it, but it is indeed 0. Negative z plus z. 7 plus negative 11. Negative 4. So this is kind of nice. Y and z both canceled each other out, yes? Can I solve for x at this point? Yeah, there's nothing saying we can't. So let's go on and finish this out. So x is -1. So that's kind of nice. Now the other equation, what we're hoping is either we get an equation with x and z or z. Because if it cancels down just to x, that doesn't help us much. We already know what x is. So for this other equation, would we add or subtract our y's? Add, because 2 plus -2, 2 minus 2 is indeed 0. Since adding will cancel our y's out, we're going to add all the way across. -x plus x. Well, that's actually 0. 4z plus z. 5z. -9 plus -11. Which will be -20, yes? This is kind of nice because now z is by itself. We can solve it by dividing both sides by 5, telling us z is -4. This one actually worked out quite nicely. What do we want to solve? Well, now the only thing left to solve for is y. Doesn't matter which equation we solve for it or use to solve it. Top, middle, bottom. Which one? Top. So we plug -1 in for x, -2y, plus -4 for z. So we plug x and y, or x and z back in. We're going to solve for y. So we can drop the parentheses. It will tell us -1 minus 2y minus 4 is equal to -11. -1 minus 4. We need -5. At this point here, we can add 5 to both sides, telling us -2y is equal to -6. Last but not least, we would both sides by -2, telling us y is equal to 3. So our solution is the point -1, 3, -4. Questions on how we got this here? You're good. Yes, I mean there is a good bit to these problems, but there's not a lot to these problems at the same time. Would we agree with that statement? It's a lot of the same thing, just doing again and again and again. Yes? Yes. Questions on this here?
I say we just skip the whole part.
This one here, I'm going to see your notes. So this here, so there are graphing calculators. The TI 89, 84 pluses that we'll start using are graphing calculators. This here is a type of graphing calculator. Let's make sure there. So we can say x plus y minus z equals, oh, I gave you another plus, equals -1. Then we have 4x plus 4y minus 4z equals -2. No solution, because those two planes are parallel. And that's part of the reason why I ended up finding this and using this, because it is kind of nice to be able to see graphically what this looks like. Now there is a point of intersection for the other one, that other plane, but doesn't matter. The other two are parallel to each other. So that would be no solution. X plus y plus z equals 8. X minus y plus z equals 8. Plus z equals 8. And lastly, 2x So if we look at this here, the last homework problem, or the last problem, number 3. So we do see there is an intersection, but that intersection is actually a line, and there's more than one point. There are infinitely many solutions for this here. Because where all three of these are intersecting, because we're looking kind of straight down on it, is a straight line. So if it's one point, it's one spot. There's that single solution here. So all three of these here, as we see here, that whole spot. Let's see, I think I'm... the solution.
numbers behind that number.
Yeah. So this here is just, yeah, it's a pictorial graph of it, but it expands out. What was the question? Numbers behind it? No. But this is a way to visually see this. Homework. 3 through 5. 11, 13.